right, let's go over this last little warm up or this practice in the first part of our Unit 5. Okay, our basic probability of discrete and independent events. All right, so here we have the blood types, okay, and so then here were those ones of the information they gave us. And so then the one that's remaining is that AB, so that's why it's 4% type AB. Now, what, so type A or type B, so that's this kind or that kind, and so that's the 52%. Not type A is going to be all the other ones besides the 42% who are type A, so that's your 58%. All right, here now we are starting to have some combined events. And so these are going to be independent events, and because the type of blood one person has is not affecting the type that the other person has, okay? So you pick two donors, and neither is type AB blood, so this one's not, and this second one is not. There you have your percent. You pick 5, and none of them are type O. So first, I figured out the probability, so all the portion that are not type O. So the complement to O is 56%. And so we want all 5 of these people to be that 56%. So that's 0.56 to the 5th power. Now you're going to pick 7 in this one, and you want at least one of them. So the probability of at least one is 1 minus the probability of none. Now let me look at some details here. We're picking 7, so I need at least one of these 7 donors to be type B blood. So 1 minus the probability that none of these 7 donors are type B blood. So that would mean 1 minus probability. So for none of them to be type B, that means all 7 of them are something else. And I think that is type B. So I came over here and I reminded myself that type B was 10%, not type B was 90%. So all 7 of them are type or something else other than type B. And so 1 minus that, and there you go. All right, this 6th donor is the first donor that has type AB. So that means not type AB for the first and not type AB for the second and not type AB for the third and so on for the 4th and for the 5th. And then this 6th one is type AB blood, the 0.04. All right. Now we're having this class, and you're going to have groups of 3. And so this is a statistics class, but they're having information about the students having had calculus, not having calculus, having to have 1 semester, and then 2+ semesters. So they just only gave me the 55 and the 32%. That was 0.87. Therefore, I deduced that the 2 or more semesters was the remaining portion of the 13%. Okay? So now, what's the probability that the first person placed into your group, so we're just talking about one person going into your group, so has some calculus, so that would be some calculus. Okay, so some calculus is 1 semester and 2+ semesters. So you could just add together the 0.32 and the 0.13, and that would be all of that has some. Or you could do 1 minus the none. So either way, adding the 2 that have them or 1 minus the others. All right, has taken no more than 1 semester. So on these no more thans, man, I don't know what it is about them, but they really make me have to stop and think. So no more than, not more than 1 semester. Not more than. Okay, so that means no 2+. Not more than 1. So 1's okay and none is okay. And so then that's the 0.52 is okay and the 0.32 is okay. And that's how we get that. So really got to think about those no more than. Man, those would mess with my mind. Okay, next. So now we're going to be talking about being part of this group of 3, and then we're talking about what happens to the other 2 members. So we're going to have picking 2 people. So we have 2 blanks here. So you can pick 2 people. Neither studied calculus. That's none and none. All right. Both studied at least 1. So that means 1 and plus 2 or more. So probability that they studied 1 semester, at least 1 semester of calculus. So that's a probability of 1 semester and 2 plus. So that's that 45% of people who have had some calculus. Okay. And then they say they want both people to have had at least some calculus. So this person has some calculus and this person has some calculus. And that's how you get that total of 0.203 or 20.3%. All right, next. At least one has had more than 1 semester. Well, more than 1 semester is that part that was 2 plus. So at least one student has had 2 plus semesters. So do you remember from the previous page, the 2 plus semesters was 13%. So at least one has had that 13% or is part of that 13%. Okay, so I got at least one. So I need to do 1 minus the probability that neither of the two people are part of 13%. None of the 2 students studied 2 plus semesters. Probability that 1 minus the probability that none studied. So this one didn't study 2 plus and this one didn't study 2 plus. So that's 1 minus both of those. Okay. I am not going to lie to you. That problem really took some thinking for me to do. I mean, maybe you're good at that, but that one kind of blew my mind a bit. I really had to concentrate to really think through those. And when I looked at a past answer key, I actually had part C wrong. And so I think I fixed it this year, hopefully. All right. Slot machine, which has 3 wheels. So there are 3 situations, 3 events, 3 spins, or 3 items to look at, and you want to get 3 lemons. So all 3 of them are the 30% of lemons. You get 3 bells, all 3 of them being the bells, only a tenth of 1%. You're not very likely to get the jackpot, okay? And you get at least 1 bar. So 40% are bar. Okay, so probability of at least 1 is 1 minus the probability that none of the 3 wheels are a bar. So in order for none of the 3 wheels to be a bar, then all 3 of them are this 0.6. So not a bar times not a bar times not a bar. So that's 1 minus none of the 3 wheels are bars. There it goes. All right. You shuffle a deck of cards and you're doing all of this stuff. The first card is red, so is the second, and so is the third. You are surprised to get 10 red cards in a row. So you start thinking the next one has got to be black. Now, keep in mind that they do replace the card back into the deck. So we do have independent events. So every time half of them are red, it's not a ongoing thing where you keep that one out. So are you correct in thinking that there's a higher probability that the next card will be black than red? And that's no, because these are independent events. Since you are replacing that card, then you still have half red, half black. So no advantage there. Is this an example of law of large numbers? It is, because we know that in the long run, if you do many trials, you're going to have 50% red and 50% black. But let me tell you something. 10 is nowhere near many trials. So, you shouldn't be getting worried, okay? I mean, there is some unlikeliness to it, but each individual one is still independent of the others. Okay? All right, so here was this actual press release of this woman. She was a 37-year-old cocktail waitress, and she played $27 in the machine and then hit the jackpot, and she got 34 million, almost 35 millions on the Megabucks machine. Well, the Nevada Megabucks has produced 49 major winners in its 14-year history. So how can the Desert Inn afford to give away such millions and millions of dollars on just a $3 bet? Well, as we talked about in class, there are many, 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 many people playing the slot machines or the machines or whatever this is that are losers. And so we know that although you're just doing a $3 bet, there's been so many more people who have lost the $3. In fact, we know that in the long run, the casino is bringing in more than the jackpots that they pay out. No doubt about it. They said it that way. So why did they issue a press release? Why would they want to expose such a huge loss? Okay, well, guess what? They want to entice people. They want to say, hey, look, come and gamble here. You're going to win. Do you know, this is so interesting. On the outside edge, if you go to a whole section of slot machines, they put the slot machines that they have calibrated to be higher probability winners on the outside edge of the slot machine area. And they have done that on purpose so that people walking through the casino will see people on the outside edge winning because those on the outside edge win more frequently. So then they're like, whoa, look at these people winning. And they go in to the middle and then they have those lower odds and they lose. So they want people, come on, play, 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 because the more that play, the more they are going to make. All right, now here we go. We've got our cars here in Alito, or 40% of the cars in Alito are manufactured in the U.S., 30% Japan, 10% Germany, and the rest are other countries. Okay, so we've got that out here. Cars not made in the USA is 60. That's all these others. Japan or Germany, or you can add those two together. The first two cars at the Bailey Ranch Road stop sign are from Japan. The first one's from Japan and the second one's from Japan. So that's 9% chance. None of the three cars at the Bearcat gas station are from Germany. So this one is not from Germany. And this one is not from Germany. And this one is not from Germany. Okay, so that's a 0.729. At least one of the, what's the probability that at least one of the cars at the Alito Pharmacy is made in the U.S.? At least one of them. Okay, well, that means any possibility except for none. So, the probability that at least one of the three is made in U.S. is the 1 minus the probability that none of the three cars are made in the U.S. And remember from the first problem A up there, not made in 60% of cars were not made in U.S. So, in order for none of the three cars to be made in the U.S., that's 0.6 times 0.6 times 0.6. There we go. All right, how about this? Out of the 5 cars that come out of the CVS parking lot, the first Japanese car is the 4th car that you see. So not Japanese and not Japanese and not Japanese and Japanese. Now, but it says out of the first 5. Well, what's happening on the 5th one? And that means, you know what? Doesn't matter. We don't care. Doesn't matter. We don't care. So that probability does not concern us. We are only referencing the order of the first 4. And G, when you go to Alito Donuts, the first car you see manufactured in another country other than US, Japan, or Germany is the 3rd or the 4th car. So let's take a look. Okay, so the first one you see manufactured somewhere, the other is the 3rd one right here, or the 4th one. Okay, so we have got really two separate scenarios. We have got this happening where we are having a situation where the first one is the third, or the first one is the fourth. And those are adding together because either one of these scenarios is acceptable. All right. Would you consider the events made in the USA and made in Japan disjoint events? Yes, because remember the definition of disjoint: no outcomes in common. So there are no cars made in both USA or Japan. They would be classified as one or the other, not both. All right, how about this one? If the events made in the USA, oh wait, hold on. My car is made in the USA and your car is made in the USA is independent, okay? So probability my car's USA 40%, probability your car's USA 40%. What does that mean? Explain. Well, if they're independent events, and I believe that to be true, then the rate, the fact that I got a US, my car's made in US has no effect, and it does not change the probability. That's the key. Does not change the probability that your car is made in. So don't say. Here's one thing I've seen people say today: one thing doesn't affect the other. We need to fix that. It's not that one thing does not just affect the other. That's not entirely everything that's important. It's it does not change the probability of what's happening to the next car. Okay? All right. And so the now roulette table, those are half black, half red. And so then what they're doing, so they describe what's going on here. If you're playing the roulette table and you spin it around, and your first 5 spins, the ball will scoot around there and land on a red. Should you pick red on the next spin since you are on a hot streak? And that is no. Each spin is independent of the other spins. The probability that the red is on the next spin is still 50%, regardless of what has happened all the times before or even on the next spin. Independent. So I don't have different probabilities because I've had such good luck coming up to this point. All right, that is the end of your packet, and I hope you are now ready for your quiz.